Alright guys, let's have a look at paper 6.1 from May-June 2018, and this is 0654 obviously. Okay, first thing we've been asked to do is we've got a spring here that we need to measure the length of. Now obviously if you're doing this online that might be quite difficult. Okay, to be honest, the values don't really matter there. You should be placing your ruler so that you can read it carefully. I've started here. That's 22 centimeters, and we're going up to 24.7 centimeters. Okay, so 24.7 minus 22 and 0, that gives me 2.7 centimeters. Okay, we just make sure we are being very, very careful when we're doing this, because my answer here is in centimeters, their answer here is in millimeters, so remember to turn that into millimeters. Okay. Common question, we're being asked to make sure that we avoid parallax, so line of sight errors, all right, when measuring the strength, measuring the length of the spring, sorry. Well, key one, make sure that your eyes are close to the ruler, and also that your line of sight is perpendicular to the spring. What does that mean? Well, if I'm trying to measure here, yeah, my eye is here, and my line of sight, okay, there's an angle of 90 degrees between the spring and my line of sight, so they are perpendicular. Okay. We're then given the readings and we're asked to use a ruler to measure this. Okay, I suggest what you do is take your own ruler, draw a horizontal line from the top and from the bottom. Okay, make sure that you're using the same method as outlined here. We're looking at the top of the spring and the bottom of the spring. We're doing exactly the same thing, but we've zoomed in. Okay, all we have to do, again, we have to convert from centimeters into millimeters. Okay, so I take this as 69.8 centimeters, and then we've got 65.9 centimeters. Difference between those guys is 3.9 centimeters, which is 39 millimeters. And I'm going to put it in my table. Okay. Here's the big bit. Okay. Now, this is actually my second attempt at this because I didn't read the instructions the first time I did it around. I'll try and dig it out for you guys. Really important during this that you follow this instruction. Otherwise, you're going to have a very difficult time. Now, I don't like the construct of this graph, but you've got to follow their instructions. Okay, the reason I don't like it is because I feel like this is very, very tight on here. If I were them, I wouldn't start the graph, the origin, but that's what they've asked you to do. You've got to do it. Okay, so we plot our data, and what you should find, well, firstly let's talk about axes, sorry. We've got 0 down here, and then we're going to a number of, I think it's the maximum value is 82, and we're going from 0 to 5 here. Don't think there's any problem on the vertical. On the horizontal, you might have a little bit of a dilemma. I went for 20s because it fit the numbers quite nicely. Okay, you're then asked to draw a best fit straight line. Okay, and again, when you've drawn your straight, I've drawn mine in pen so that you can see it more clearly. After I did it, I did think, you know what, maybe my line is a little bit out. If I were to draw it again, I might kind of tilt it just that little bit more. Okay, the reason being that this guy is on the lower side, kind of on the lower side, and then on the line. So I've got a bit too much of a spread towards the lower side. If I tilted my ruler a little bit more, then I would find that actually it just kind of cuts nicely. But I think this would be fine for CIE's sake. Okay, don't worry about this line M, we'll talk about that in a second. You're then asked to use your line to find the length L0 of the unstretched spring. Now, how we do that? Well, we know that F equals 0, so therefore force equals 0, we've got no load. And so therefore my spring is going to be unstretched. We're plotting here length here, not extension. Okay, so this is my L0. Alright, this value of the intercept where I cut my x-axis is my L0 value. And in my case that was 28. Okay, bear in mind I measured it to be 27 at the previous one, so I'm pretty happy with that. Linked to that question is the follow-up, which is state whether your answers agree within an experimental accuracy, and remember the guiding rule for this is 10%. If there's a difference of 10%, if there's a difference of less than 10%, then you're okay. Well, 28 and 27 are definitely within 10% of each other, and so therefore they agree. But remember to write a statement. Don't just write yes, it agrees. Tell me why and give us a reason for it as well. My reason going along those lines of it's less than 10% difference and therefore they agree. Last one, gradient, the line measures the force constant. The greater the force, the harder it is to stretch, and so therefore the stiffer, and therefore what we're expecting you to draw is something which is steeper. Now actually, this line could be, I've done mine starting at the same point as my original line. To be honest, you could draw this line anywhere on here as long as it has a steeper gradient. Okay, so anywhere here, here, here. The reason I've drawn it here is to make it easier to compare. Alright, I think it makes much more sense. I could draw any line which is steeper, as long as it, in my opinion, cuts that same point here so that you can allow the comparison with your original line that you drew. And also, last point, remember to label. Okay, again, a lot of people don't label with M. Who knows what would happen if you didn't do it? It would be a silly thing to do to forget that.